Welcome back, everyone, for this next session. And I have to say, when I read the description for this presentation, I thought, these guys really know their audience, because it's true, isn't it? As a conference goer, it's just one thing to build a demo, and it's another thing entirely to put it into production. So I'm excited to see what these guys have to say. Please welcome to the stage Motafer and Abdel, and they are going to take us through production GenAI and CAP beyond the demo.
Hello and welcome, everyone. Thank you for joining us today, and thanks for the intro. Also, thanks for the SAP reCAP team for such a well-organized event. And as you see from the title, Production GenAI and CAP, right, from the demo to a production solution. And we promised you stories and looks behind the scene, and that's what we hope to accomplish in the next 20 minutes. All right. This is where we started 2.5 years ago. That's the prompt. The whole product was this file. 100 lines of code, GPT-4 as a model after it was released a couple months, and we had the API key in the env file. And we've all written this exact code, right? And it worked. Customers loved it. And that was the trap, right? When customers love something, it's no longer a demo, it's no longer a POC, and it has to work in production. And it was a battle and a journey. And this was our timeline. It started as a proof of concept with internal demos first, then real deployments, and at the peak we had 3 running instances, and they were all basically 3 copies of the same application. 1 for our internal system, of course, and 2 for our first 2 customers. One of those clients had a recommendation, had a requirement to migrate from ECC to S4. And our tool basically enabled what no human could enable in a short amount of time, right? You have an old ECC system, has a lot of customizations, has a lot of code, and if you want to migrate, you need documentation, and if you don't have documentation, then basically you need to rely on your consultants and their knowledge, and that takes time, right? So that's where CodeGenie comes in place, is that we take that time, that takes sometimes months and even years for certain customers, and we bridge it down into a couple of, I would say, weeks, but eventually a couple of days. So yeah, that was the first period. Single tenant application. It was a CAP application deployed in Cloud Foundry in the BTP environment, and it was fully on SAP infrastructure, but it was a single application. No multi-tenancy, so we cannot roll it into multiple customers. And that's when leadership came in and said, this needs to become a SaaS product, right? And multi-tenancy, though it's a flag in the MTX sidecar for all those Node.js and Java people, it's not actually a feature. It turned out to be a complete product rebuild. And 7 months after that, with multiple attempts, that merge went into production one morning. I had a major incident, reverted back, and yeah, that same afternoon we had our first version of a multi-tenant SaaS solution that is CodeGenie. And that's the middle one. And though the first one looks longer, that's where we had our most I would say, walls and obstacles, and this is what we will share with you today. The first one. Today, agentic AI is everywhere. You hear it left and right, but at that time, we needed something to work, right? And first lesson, there is no God model, right? Each operation has its own specificities, and it requires a specific model. Some operations need longer context, others need shorter context, and we needed to have that option in our application. I'll show you quickly this code. And as simple as it is, it actually helped us make our application more able and basically enable that first GenAI experience where you have an input and you have GenAI respond for that specific input. We had 14 cases, each reading its own settings. We had a specific provider. In this case, you can see we have a provider name, model name, and max token for each case. We needed specific ones to generate documentation. We needed specific ones for the long documentation because of the long context. And at that time, everyone were like, okay, OpenAI is the best, right? GPT-4, when it came in late 2023, it was the best, right? Well, it has a limited context window, right? And then Google released its Gemini suite, right? Gemini 1, 2, and 3. So as a provider and as a product company, you need to be ahead of the curve and up to date as to what new models enable your certain features of your applications, right? And so it's very simple, and I really like this slide because it shows that don't use one God model, have a dedicated LLM for each of your operations. And this is how it looks. For example, here we have a default setting. It's full of parameters. Maybe it speaks to some of you. And actually, with a quick show of hands, who has worked with any GenAI resources from SAP, like GenAI Hub, SAP AI Core? Okay, we have some experienced folks here. Okay, so this speaks to you, right? You have your Gemini models for long context because it has a million tokens. And then if you want something, let's say, more streamlined, more precise across all shorter contexts, then you have your GPT family models. Right. And this is also my favorite, second favorite slide, which is the agentic tool loop. And the reason why I like this one is because even though we hear about agentic workflows, tool calls, orchestration, and so on, this is actually what it looks like to have a tool definition. And this is the standard from OpenAI, the JSON format. And if you define it this way and give it to your LLM, if it's a GPT or a Gemini or even the models from Anthropic, they would understand how it works and they'll be able to call it in your agentic workflow. So an AI-style function with 5 tools and needs to be capped. And this is what enables that agentic experience, right? And then we hit our second wall. In 2024, you wouldn't hear about the vector engine or the embeddings in SAP, so everyone was coming from the pioneers at that time, LangChain and such, and we had to migrate from Pinecone to SAP HANA database at that time, and it turned out to be much simpler than we expected, to be honest, and the retrieval basically is one SQL command. It has embeddings. It has the vector types in CDS, so we could integrate it with our application. And but at that time, we were a bit naive, and we needed something to work at the same time, right? So we put everything in basically one chunk, and it worked. And this is where our second wall in the same aspect came in, is that we have a pipeline, we're able to ship something that works, that retrieves, that is based in facts, but it's not always that accurate. And that wasn't also a problem after all, because with chunked embedding, we were able to have more accuracy, more consistency across multiple runs, and that was all possible thanks to the HANA vector engine. I will show you what it looks like under the hood, and it's as simple as an annotation in CDS. Here you have your vector type in CDS, with 3,072 dimensions. So nothing exotic, it's all native in HANA. And that's the point. And this one is basically under the hood of the RAG itself. That HANA query is basically what we run every time we need a RAG-enabled query. You can see that after having embedded the user query into a vector string, we pass it to the real HANA vector function that is native in HANA. And basically, we have the cosine similarity, which what compares the vectors, and it gives you your similarity based on your knowledge base, right? And that's what we ship. And though it's not exotic, it worked, and it was consistent and scalable at the same time. And then came augmented RAG, right, with hybrid search. And this is actually a good lesson because even though something works, it does not mean that it cannot break. And for certain use cases, we noticed that users were actually asking very specific questions, and this is a known pitfall for RAG at that time. So we needed something to fix this. And luckily, HANA also supports fuzzy search. And we were able to do algorithmically a combination of semantic search based on cosine similarity and also retrieval of keywords-based search, right? It's your standard fuzzy search in query elements, for example. And honestly, it solves a lot of use cases, and it even improved our precision. And yeah, this also shows that it's fairly simple if you want to have a RAG pipeline built entirely in HANA, and this is our basic function that returns the results. And with that, I will leave the floor to my colleague who will talk about the next couple of walls that we faced in our journey.
Hello. Thank you, Mudafer. So for the third wall, the AI SDK isn't really multi-tenant. For our first 14 months, tenant wasn't a variable, right? So then we made it one. And we spent 7 months to chase everything that assumed it wasn't. So data was easy. It's just like cap plus MTX. Our sidecars gives you an HDI container, your schemas, everything is isolated per tenant. But there is nowhere tenant anywhere. I'm saying where, the close. So the SAP AI SDK itself is not multi-tenant. Why? Because of its deployment cache. It has no tenant in its key. That's what happened to us. And it assumes one tenant per process, and one process serves all tenants. And that's a problem. So cross-tenant deployment leakage was a default behavior. And we had to come up for a fix for that. So let me talk more about this cache problem, okay? So let's assume the app started. If you're lucky, we have the first user logged in and sent a request. Okay, it sent with it the deployment ID, user groups, and everything for SAP AI Core to work. And it cached this, and then the user sent again a request, it will work, right? But if in a second tenant, another user will send a request, well, that's a problem, because we have cached values from the first tenant. SAP AI Core will refuse the request. So what we did is we come up with a part of our rebuild. We made the SDK multi-tenant by a monkey patch that patch the deployment cache. So in the deployment cache, we've added the key that equals the tenant and ID. And that's how we fixed it. And again, we have run into the same issue, but in a different way. npm install, just a month ago, it has added another nested version of the AI API from the SAP AI Core SDK. And guess what? When using SAP orchestration, it has used the second version, which wasn't patched by our patch. Our patch only targeted the first version. So what we did again, we have pinned the version that it hasn't nested SAP API, and we also hardened the patch. So each request that is not patched, it is refused. So that's what we did. So we refused the AI call rather than serve it with a broken isolation. So let me show you. Here, as you can see, that's how we create the tenant-aware cache. We take from the bindings. Why? Because in multi-tenancy, we have the sub AI core instance in the subscribers tenant. So each call from the front end, it sends back the tenant ID and also all what we need to get the sub AI core subscription. And also for the guard, this is our guard. So if the request is not patched, we're gonna refuse it. If not, we're just gonna create the instance for orchestration clients. And that's it, next to our next wall. So here we have streaming versus the 30-second window. So in the first versions of our chatbot, when you send a message, you had to wait. And if it was really something that more complicated and needed to generate more tokens, that means more seconds. So there's like, the default is 30 seconds, and the gateway app router will close the connection. So what's the solution? Of course, implementing streaming. And guess what? In CAP, that's native. So literally, it's one annotation in the service. That's it. And it's implemented. This is our CDS. We just put WebSockets with OData. And then that's the implementation. And also, we have implemented the abort controller. So in orchestration streaming, we have abort controller. Also, we extract the GWT. And if a user cancels the request, it comes back, and the controller will abort the request and stops generating tokens. So now we do a demo for ChatGenie.
Thanks.
Okay. I leave you with Mudafer. Thank you.
Yeah, that's a lot of technical talk, a lot of code, a lot of words that are on screen. So let us see what is this CodeGenie app, right? Let's see, how can I do this? Okay. I have to log back in. Demo, right? Let's hope this goes quick. Hopefully that's it.
Yeah.
All right. Let us both, let me increase this one. Okay, that's the most I can increase. Okay, let me see. Okay, I cannot. Do you guys can hear it? Can read this? Okay. So basically what it says is, are there custom CDS views I can reuse to replicate the data model behind the overdue account receivables? And this is a question that any consultant might have, right? And what's best to have this question answered than to have our tool answer it? All right. Bear with me. All right. So this is our screen. Fairly simple, 30 elements, few lines of code. But this is where the magic happens. I've pasted my question, and let's see what happens. I see my name. That's good. Okay, and then a lot of stuff happened, right? Have a response. We have some links. So let's walk through this. The agent said, I'll search for custom CDS views related to the overdue accounts receivables, and then it responded with a bunch of stuff. So this is, from the looks of it, a CDS view. And you can see that we can show side by side what the agent has responded with, right? These are not hallucinations. This is not your ChatGPT telling you your grade. This is it. This is our evidence-based agent, right? And it basically answered. It gave you the CDS views you're looking for, and even organized them by type. These are data definitions, and here we have a view. And you can read the documentation that we generated for that object. And this is basically the result of everything we just discussed, right? We needed an LLM for the operation. We needed multiple LLMs for different operations. Aside from the fact that this needed to be a multi-tenant solution to ship for different customers with different database schemas and have that tenant isolated. We also had to implement RAG for evidence-based generation. And then we had to implement advanced RAG with hybrid search, enabling both similarity search and keyword-based search. And this is what it looks like. And it's all in SAP, all in BTP, in Cloud Foundry, using the Cloud SDK, using the SAP AI Core orchestration library from SAP, and with a small monkey patch of our own. And yeah, this is what it looks like. But this is not enough, right? If you've been a product engineer or you've worked on a product at a certain point, you know that this needs to be productive, which means that there are bugs, there are errors. Sometimes the LLM hallucinates even with RAG. So you need to build an ecosystem around everything, from CI/CD to observability to monitoring and debugging. I will show you how we do these, and again, a couple of lessons and some walls that we had to surmount. Let me see if I can switch back everything without breaking anything. Okay, seems to be working. So yeah, the day two ops. Those are the ones that pay the bill, right? And it's an unglamorous wall. When you're in front of the screen, you have your product owner who says, that customer has a bug and we need to fix it. But yeah, where do you begin, right? So yeah, every AI call in the suite itself is logged, of course. And what we just saw is logged and streamed into HANA, of course. And we've built a couple of tools around this. So this is how it looks. It's fairly simple. You need to log your cost, of course. You need to log number of tokens. You need to log how much time it took, what kind of errors. But this was very simple, and it worked. But this is not the end result. What we built is even more complex and more detailed, and it's all in HANA, where we trace every agent step, every tool call, every model decision, so that when that ticket comes in on a Friday afternoon and you have to go home at 7 p.m., you know where to look and have, let's say, a way of work in terms of fixing bugs in a multi-tenant SaaS solution that is deployed on BTP, that is consumed by subscriber sub-account. Each of them have their own tenant schema for the database. And this is what it looks for the monkey patch. For the retries. And this is our first guardrail. When there's an error, when the model does not know what to decide, what to do, we basically inform the user. It saves us a lot of trouble, but it's also not enough because it also can refuse legitimate questions. And yeah, so we need to be able to debug. Before going into the BTP stack, I don't know if we have enough time for another demo, but I would love to show you something. We have four minutes, right?
We have 0.
Okay. So, yeah. This is my cloud agent, right? And so quickly, this is what observability looks like for me. So instead of having to go into BTP, we all know the Database Explorer in HANA. You have to log in. You have to look for your tenant. You have to switch tables. You have to go into different tenants in order to find that bug. Then you have to go into Kibana dashboard. It all works, right? It's all in BTP, but it's not practical. So with my agent, I have a skill that basically uses the HANA JavaScript library, and I ask it, okay, this is my tenant that we just saw, and I give it the chat ID, and in a couple of seconds, it gives me everything that happened. It's not just about the cost, about which prompt version that was shipped. This tells me exactly what happened. I can zoom in, I can go into detail on each area, but this gives me like that first look where it could go wrong, right? Is it the reg pipeline? Or is it the library itself? Or is it like a streaming issue? Maybe it's a UI issue, right? And this helped me save hours of useless investigation. And yeah, this is a lesson that for me is worth sharing. And you have your little message at the end that tells you, okay, was this a healthy turn? Maybe it was latency. Maybe we need to reach out to SAP for something because it doesn't always go into plan. And this next thing I want to show you is also a game changer for us. If you've worked with the GenAI Hub, you know that RPM is set by default, right? I think for GPT it's 78, and you need to increase this. Before, it was like you needed to go into the ticket, the support center, and you needed to create ticket. But for us, that was not possible, right? And since SAP AI Core released a version where you can actually call an API endpoint to increase your RPM, we basically built an entire application around this. And I hope this works. Again, we'll log in. Okay, I'll just stick to the presentation, guys. I know I'm running out of time, and I apologize. So I'll just stick to the presentation. Unfortunately, I have to skip the CI/CD, but again, this is all in BTP. We use the CI/CD service and the TMS as well, and this helps us ship fixes quickly and deliver new versions into production. With the few seconds that I have remained, I want to talk to you about scalability. And as you can see on the top right, you know, this is great and all, but when you want to scale and you want to onboard multiple customers, you can't do things manually, right? And we built an application just for this goal. This application basically uses Terraform and a couple of GitLab runners to provision the sub-account, have the subscriptions, have the resources, the destination, the configuration, and everything. And a huge thanks to Mr. Gregor Wolf. I don't know if he's here, but this is what it's all about, right? That open source community, that's what we're all here, and that actually helped us, you know, find solutions, find patterns, and everything. And yeah, this is our last wall. And to finish, these are the 6 lessons that we learned. We went from a POC, a template, 100 lines of code into an application that serves more than 150 tenants in 2 different regions, and one in the US and one in Europe, with data residency, with multi-tenant isolation. And if you take anything from the talk today, is you can do this entirely on BTP. Thank you.
Thank you very much for sharing your experiences, your knowledge, your struggles, and everything. Here in 1 minute, we went from beyond the demo, and we're going on to beyond vibe coding, and that will be very shortly.